February 19th, 1945, Iwo Jima's black volcanic beaches. Lieutenant James Morrison of the 28th Marines knelt beside a Type 92 battalion gun abandoned in a hastily dug revetment near the base of Mount Suribachi. The weapon sat at an odd angle, its barrel pointed uselessly toward empty sky, surrounded by scattered ammunition boxes and personal effects left behind by Japanese gunners who had fled inland. Morrison ran his hand along the barrel, noting the crude welding marks and irregular bore wear. He called over Corporal Thomas Hendricks, a former machinist from Pittsburgh who had worked in his father's metal shop before the war. "Take a look at this, Corporal. Tell me what you see." Hendricks examined the weapon with a professional eye, checking the breech mechanism, sighting down the barrel, testing the elevation and traverse controls. After several minutes, he stood and shook his head with something between disbelief and contempt. "Sir, this thing's a piece of junk. The barrel's not properly rifled. See these inconsistencies? The tolerances are all wrong. The recoil mechanism is primitive, probably salvaged from an older design. And look at the sighting equipment. It's like something from the last war. I'd be surprised if this gun could hit a barn at 100 yards, let alone a moving target." Morrison nodded slowly, absorbing the implications. American intelligence had known for years that Japanese artillery lagged behind Western designs, but seeing the evidence firsthand drove home just how wide the technological gap had become. This wasn't simply a matter of inferior resources or wartime shortcuts. This represented fundamental limitations in manufacturing capability, quality control, and design philosophy that permeated every level of Japanese military production. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from. Today, the discovery of that single artillery piece on Iwo Jima's beaches was merely one visible symptom of a much larger story, a story that had been unfolding since the earliest days of Japanese rearmament in the 1920s and 30s. It was a story about industrial capacity, technological development, and the brutal mathematics of modern warfare. It was also a story about choices made decades earlier that would ultimately doom Japan's military ambitions, choices that seemed reasonable at the time, but would prove catastrophic when tested against American industrial might. To understand how Japanese artillery fell so far behind requires understanding Japan's industrial development in the decades leading up to the Second World War. Unlike Western powers that had built their military capabilities on top of mature industrial economies, Japan attempted to create a modern military while simultaneously developing the industrial base to support it. The result was a military that looked impressive on paper but suffered from systemic weaknesses that became apparent only under the stress of prolonged combat. Japan's modernization began in earnest during the Meiji Restoration of 1868, when the nation opened itself to Western technology and ideas after more than 2 centuries of isolation. The transformation was remarkable. Within 50 years, Japan had gone from a feudal society to a recognized military power capable of defeating Russia in the War of 1904 to 1905. But this rapid modernization came at a cost. Japan lacked the raw materials, the skilled labor force, and the accumulated technical knowledge that Western nations had developed over generations of industrial evolution. Japanese military planners recognized these limitations, but believed they could be overcome through imported technology, intensive training, and superior fighting spirit. They were partially correct. Japanese soldiers and sailors proved themselves capable of extraordinary feats of courage and endurance. Japanese tactical doctrine emphasized aggressive action, surprise, and the psychological impact of audacious attacks. These qualities brought spectacular victories in China and Southeast Asia during the early months of the Pacific War. But underneath the surface, successes lay structural problems that no amount of courage could overcome. Japanese industry simply could not produce weapons in the quantities or quality necessary to match American output. More critically, Japan's technical and engineering base was too narrow to keep pace with the rapid technological evolution that characterized the Second World War. Artillery provides perhaps the clearest example of these limitations. The Type 92 battalion gun that Lieutenant Morrison examined on Iwo Jima was designed in 1932, based on principles and technologies that dated back to the First World War. It was a 70mm weapon, lighter than comparable American or German guns of similar role, with a maximum range of approximately 2,800 meters under ideal conditions. The gun could be broken down into components for transport by pack animals, making it theoretically well suited for the mountainous terrain where Japanese forces often operated. In practice, the Type 92 suffered from numerous deficiencies that became apparent when Japanese forces faced American firepower. The lightweight design meant thin barrel walls that wore out quickly under sustained firing. The limited range meant Japanese gunners had to position their weapons dangerously close to frontline positions to be effective. The simple recoil mechanism produced excessive barrel jump, degrading accuracy. And the ammunition, produced in factories with inconsistent quality control, often failed to perform to specification. American Marines who encountered Japanese artillery fire consistently reported that it was far less accurate and less devastating than German artillery on the European front. Forward observers noted that Japanese guns seemed to lack the precision to conduct effective counter-battery fire or to deliver concentrated barrages on specific targets. Even when Japanese artillery achieved surprise, firing from concealed positions at American troops caught in the open, the results were often disappointing from the Japanese perspective. Captain William Hawkins, an artillery officer with the 5th Marine Division, kept detailed notes throughout the Iwo Jima campaign. His observations, preserved in his personal papers now held at the Marine Corps Historical Division, provide insight into how American artillerymen assessed their Japanese counterparts. Hawkins wrote that Japanese guns appeared to be sighted primarily for direct fire at close range rather than for the indirect fire missions that dominated American artillery doctrine. Japanese gunners seemed to lack the surveying equipment, communications, systems, and fire direction procedures that allowed American artillery to deliver accurate fire at long ranges. More fundamentally, Hawkins noted that Japanese artillery units appeared to operate independently, without the coordination and massed fires that made American artillery so devastating. When the 5th Marine Division called for artillery support, multiple batteries could concentrate their fire on a single target within minutes, directed by forward observers who communicated via radio with fire direction centers that calculated precise firing data. Japanese forces lacked comparable communications infrastructure and fire control systems. Their artillery tended to fire independently, each gun engaging targets as individual gunners identified them. The technological gap extended beyond the guns themselves to every aspect of artillery operations. American artillery units employed sophisticated fire direction procedures based on mathematical calculations that accounted for range, elevation, propellant temperature, barrel wear, wind speed and direction, and numerous other variables. Forward observers used precision optical instruments to calculate target locations and adjust fire. Communications relied on portable radio systems that kept forward observers in constant contact with fire direction centers. Japanese artillery relied on simpler methods that required gunners to be close enough to see their targets directly. When indirect fire was necessary, Japanese gunners used basic estimation techniques that produced acceptable results at short ranges, but became increasingly inaccurate as distance increased. The lack of sophisticated fire control meant that Japanese artillery could not deliver the kind of responsive, accurate fire support that American infantry took for granted. The ammunition itself reflected broader industrial limitations. American artillery shells were manufactured to precise specifications in factories equipped with quality control procedures that ensured consistent performance. Propellant charges were carefully measured, fuses were reliable, shell casings were uniform. Japanese ammunition suffered from inconsistent quality that affected both accuracy and reliability. Propellant charges varied in power, causing shells to fall short or overshoot. Fuses sometimes failed to detonate or detonated prematurely. Shell casings showed manufacturing defects that occasionally caused weapons to malfunction. These problems stemmed from limitations throughout the Japanese industrial system. Japanese factories lacked the precision machine tools necessary to manufacture components to tight tolerances. Quality control procedures were less rigorous than in American factories. Skilled machinists and technicians were in short supply, and training programs could not produce them fast enough to meet military demands. Raw materials shortages forced manufacturers to use substitutes that degraded performance. The story of Japanese artillery is ultimately a story about industrial capacity and technological sophistication. Japan entered the Second World War with an industrial base perhaps 1/10 the size of America's. Japanese steel production in 1941 totaled approximately 7 million tons compared to American production of nearly 90 million tons. Japanese production of machine tools, precision instruments, optical equipment, and electronic components lagged even further behind. These limitations meant that even when Japanese engineers designed excellent weapons, factories often could not manufacture them in adequate quantities or to necessary specifications. The contrast became even more stark when considering American artillery development during the war. The M1 105mm howitzer that equipped American field artillery battalions was a sophisticated weapon that incorporated decades of accumulated technical knowledge. The gun featured a variable recoil mechanism that absorbed firing stress, while minimizing movement. The breech design allowed for rapid, sustained fire. The carriage provided stable firing platform with 360-degree traverse. The sighting equipment enabled accurate indirect fire at ranges exceeding 11,000 meters. But the gun itself was only part of the system. American artillery doctrine emphasized massed fires, with multiple batteries coordinating their fire on single targets. Forward observers operated close to frontline infantry units, identifying targets and calling for fire missions. Fire direction centers calculated precise firing data and transmitted it to gun crews via radio. The entire system was designed to deliver devastating concentrations of high-explosive shells on target within minutes of identification. The effectiveness of American artillery became legendary among both American and Japanese forces. Marine infantrymen advancing across Iwo Jima's volcanic terrain knew that if they encountered serious resistance, could call for artillery support that would arrive quickly and accurately. Japanese soldiers dug into fortified positions learned to dread the whistle of incoming shells, knowing that once American artillery located their positions, the bombardment would be relentless and precisely targeted. Japanese defenders on Iwo Jima attempted to counter American artillery superiority through elaborate fortifications and defensive tactics. They dug tunnels deep into the volcanic rock, creating interconnected positions that could survive even direct hits from large-caliber shells. They positioned their own artillery in caves and reinforced bunkers that protected guns from counter-battery fire. They practiced strict fire discipline, holding their fire until American troops came within point-blank range, where Japanese guns might have maximum effect. These tactics achieved some success. American casualties on Iwo Jima were severe, with nearly 7,000 killed and more than 19,000 wounded during the 36-day battle. Japanese defenders inflicted these casualties despite being vastly outgunned and outnumbered, but the tactics were fundamentally defensive and could not alter the battle's outcome. Once American forces located Japanese positions, overwhelming firepower could be brought to bear. Artillery, naval gunfire, aerial bombardment, tanks, and flamethrowers systematically reduced each defensive position. The capture of Japanese artillery pieces provided American forces with tangible evidence of the technological gap. Marines who examined captured weapons often expressed surprise at their crude construction and primitive design. Some pieces showed evidence of battlefield repairs using whatever materials were available. Others had clearly been manufactured in small workshops rather than modern factories. The contrast with American weapons, which were produced in vast quantities to exacting standards, could not have been more stark. Lieutenant Morrison's discovery of the Type 92 on Iwo Jima's beaches prompted him to write a letter to his father, a professor of mechanical engineering at MIT. The letter, preserved in the Morrison family papers, revealed the young officer's attempt to understand what he was seeing. Morrison described the Japanese gun in technical detail, noting the manufacturing shortcuts and design compromises. He concluded that Japanese industry was operating under severe constraints that prevented production of weapons comparable to American designs. Morrison's father responded with his own analysis, drawing on his knowledge of industrial engineering and manufacturing processes. He explained that producing precision weapons required not just factories and workers, but an entire industrial ecosystem, including specialized machine tool manufacturers, precision instrument makers, quality control laboratories, technical schools, producing trained engineers and machinists, and research institutions developing new technologies. America had built this ecosystem over decades. Japan had attempted to create it in a fraction of the time, while simultaneously fighting a war that consumed resources faster than they could be replaced. The elder Morrison's letter touched on something that American military planners had understood since before Pearl Harbor. Japan simply lacked the industrial capacity to sustain a prolonged war against the United States. Japanese leaders had understood this as well, which is why they had gambled on a short war that would secure resource-rich territories and establish a defensive perimeter too costly for America to penetrate. The failure of that strategy meant Japan would have to fight exactly the kind of attritional conflict its industrial base could not support. Artillery was just one dimension of this industrial competition, but it was a critical one. In modern warfare, artillery inflicted more casualties than any other weapon system. Armies that could mass artillery fires effectively gained enormous advantages in both offensive and defensive operations. The American military's ability to coordinate artillery, naval gunfire, aerial bombardment, and armor into integrated fire support plans gave American infantry decisive advantages in nearly every engagement. Japanese forces attempted to compensate for their artillery weaknesses through alternative tactics. They emphasized nighttime infiltration attacks that closed with American forces before artillery could be effectively employed. They dug elaborate tunnel systems that provided protection from bombardment. They positioned troops in dense jungle or rough terrain, where artillery effects were diminished. These tactics sometimes succeeded tactically, particularly early in the war when American forces were still developing their own doctrine and procedures. But as the war progressed, American forces learned to counter Japanese tactics while simultaneously improving their own artillery effectiveness. Forward observers became more skilled at identifying targets in difficult terrain. Fire direction procedures were refined to deliver more accurate fires more quickly. Ammunition supplies became more abundant as American industry ramped up production. New technologies like the proximity fuse, which detonated shells at optimal height above ground for maximum fragmentation effect, multiplied artillery lethality. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. By 1945, when Marines landed on Iwo Jima, American artillery had reached a level of effectiveness that Japanese forces simply could not match. The 5th Marine Division alone had 54 105mm howitzers and 12 155mm guns supporting its advance. Naval gunfire from offshore battleships, cruisers, and destroyers added the equivalent of hundreds more heavy artillery pieces. American air superiority meant that aircraft could deliver additional firepower on call. Against this overwhelming advantage in firepower, Japanese artillery could accomplish little more than nuisance harassment. Japanese gunners fought bravely, often manning their weapons until killed by counter-battery fire or overrun by infantry assault. But courage could not overcome the fundamental disparities in numbers, quality, and effectiveness. The Type 92 battalion guns that Japanese forces deployed on Iwo Jima were obsolete weapons wielded by brave men fighting a losing battle against an enemy whose industrial might they could not hope to match. The laughter that Lieutenant Morrison and his Marines reportedly shared when examining that captured Japanese gun was not cruel mockery of enemy soldiers. It was the reflexive response of men who suddenly understood just how one-sided the industrial competition had become. These Marines had trained on American weapons, had seen the vast quantities of supplies flowing from American factories, had experienced the effectiveness of American artillery support in previous campaigns. Encountering a Japanese gun that couldn't reliably hit targets at 100 yards made viscerally clear something they had understood intellectually, but perhaps never felt so directly. Japan was fighting with one hand tied behind its back, limited by industrial and technological constraints that no amount of courage or tactical skill could overcome. The implications of that laughable artillery piece extended far beyond a single weapon abandoned on a volcanic beach. It represented the culmination of choices made in Tokyo decades earlier, choices that seemed prudent at the time, but would prove fatal when tested against the full weight of American industrial power. Japanese military planners in the 1920s and 30s had faced an impossible dilemma. They needed to build a modern military capable of projecting power across Asia, while simultaneously developing the industrial infrastructure necessary to support that military. The solution they chose was to prioritize quantity over quality in many areas, accepting technological compromises in exchange for more weapons in the field. This approach worked brilliantly against opponents who suffered from similar or worse limitations. Chinese forces in the 1930s lacked the industrial base to produce modern weapons in any quantity. British, Dutch, and American colonial forces in Southeast Asia were undermanned, under-equipped, and led by commanders who had grown complacent after years of garrison duty. Against these opponents, Japanese forces, with their emphasis on aggressive tactics, superior training, and willingness to accept casualties, achieved spectacular victories that suggested their approach was vindicated. But America was different in ways that Japanese planners either failed to understand or chose to ignore. American industrial capacity was not merely larger than Japan's. It was fundamentally different in character, built on generations of accumulated technical knowledge, supported by vast natural resources, and capable of rapid expansion when mobilized for war production. When America entered the war, its factories didn't just produce more weapons than Japanese factories. They produced better weapons, manufactured to higher standards, incorporating more sophisticated technologies, and delivered in quantities that defied Japanese comprehension. The story of artillery illustrates this disparity with stark clarity, but the pattern repeated across every category of military equipment. Japanese aircraft that had dominated the skies over China and Southeast Asia in 1941 and 1942 were outclassed by American fighters and bombers by 1943. Japanese ships that had seemed formidable in the war's early months were systematically hunted down and destroyed by American submarines, aircraft, and surface vessels equipped with radar and other technologies that Japanese forces could not match. Japanese tanks that had proven adequate against Chinese forces were hopelessly obsolete when facing American armor. The human cost of these technological disparities was immense and fell disproportionately on Japanese soldiers who found themselves fighting with inadequate weapons against an enemy that seemed to possess unlimited resources. Private First Class Tadashi Kono, a gunner with the 109th Division on Iwo Jima, kept a diary that was recovered after the battle. His entries from late February 1945 paint a devastating picture of what it meant to fight with obsolete artillery against American firepower. Kono described his unit's Type 92 gun, which he noted had been manufactured in 1937 and showed signs of extensive wear. The barrel had been rebored at least once, probably more, degrading accuracy. Ammunition was in short supply, with strict orders to fire only when targets were certain. The recoil mechanism leaked hydraulic fluid and required constant maintenance that Kono and his fellow gunners attempted with improvised tools and materials scavenged from damaged equipment. On February 23rd, Kono's unit attempted to engage American Marines advancing near Hill 362. The gun crew managed to fire 6 rounds before American counter-battery fire located their position. Kono described the experience in terms that conveyed both professional frustration and existential terror. The Japanese gun fired slowly, each round requiring manual loading and careful aiming. Between rounds, the crew had to wait for the recoil mechanism to return the barrel to firing position, a process that took precious seconds. Even when rounds landed near American troops, the explosions seemed small and ineffective compared to the massive detonations from American artillery. Then, American counter-battery fire arrived. Kono described shells that exploded with such violence that the ground itself seemed to heave. The volume of fire was unrelenting, round after round crashing down around the Japanese position, with precision that spoke to sophisticated fire direction procedures. Within minutes, 3 of Kono's 6-man crew were dead or seriously wounded. The gun itself was damaged beyond field repair when a shell landed directly in the firing pit. Kono and the surviving crew members abandoned the position and retreated deeper into the tunnel system that honeycombed Iwo Jima's interior. Kono's diary entries from subsequent days reveal a soldier grappling with the realization that his side was fighting a war it could not win. He wrote about conversations with other soldiers who had fought in China and the Philippines, men who had believed in Japanese superiority until they encountered American forces. These veterans spoke quietly, away from officers who might accuse them of defeatism, about the futility of fighting an enemy whose supplies never ran out, whose wounded received medical care while Japanese wounded died for lack of medicine, whose artillery could be called down in devastating quantities within minutes, while Japanese gunners rationed ammunition and fought with worn-out weapons. The psychological impact of technological inferiority cannot be overstated. Japanese soldiers had been indoctrinated to believe that spiritual strength and fighting spirit could overcome material disadvantages. The reality they encountered on islands like Iwo Jima shattered that belief. Private Kono's final diary entry, dated March 2nd, expressed thoughts that countless Japanese soldiers must have shared but could never voice officially. He wrote that courage was meaningless against enemies who could kill from distances where bravery could not reach, that fighting spirit could not make obsolete weapons effective, that dying for the emperor was honorable, but dying uselessly while achieving nothing was merely tragic. American forces, for their part, gained a profound appreciation for what industrial superiority meant in practical terms. Corporal Hendricks, the machinist who had examined the captured Type 92 with Lieutenant Morrison, wrote letters home to his father, describing what he had learned about the relationship between manufacturing capability and military effectiveness. Hendricks explained that the primitive quality of Japanese artillery reflected not lack of effort or skill by Japanese workers, but fundamental limitations in Japan's industrial infrastructure. Japanese factories lacked the precision machine tools necessary to manufacture artillery barrels to proper specifications. This wasn't simply a matter of buying equipment. Precision machine tools required specialized steel alloys, sophisticated control systems, and skilled operators trained over years of practice. The entire supply chain had to exist, from raw materials through multiple stages of manufacturing to final assembly. America had built this supply chain over generations. Japan had attempted to create it in a few decades while fighting a war. Hendricks noted that examining captured Japanese weapons had made him appreciate what he had previously taken for granted. Every American artillery piece was manufactured to exacting specifications that ensured consistent performance. Every shell was precisely machined so it would chamber smoothly and fire accurately. Every component was tested and inspected. Quality control procedures caught defects before they reached the field. When problems occurred, replacement parts were readily available. Maintenance procedures were standardized and supported by detailed technical manuals. The entire system worked because generations of engineers, machinists, and industrial planners had built infrastructure that made it work. The battle for Iwo Jima demonstrated the ultimate expression of American artillery superiority. During the 36 days of fighting, American artillery units fired more than 450,000 shells at Japanese positions. Naval vessels offshore added another 23,000 tons of shells, from guns ranging from 5-inch destroyer weapons to 16-inch battleship rifles. Aircraft dropped thousands of tons of bombs. The sheer weight of explosives delivered onto Iwo Jima's 8 square miles exceeded anything previously seen in the Pacific War. Japanese defenders had no comparable firepower to bring to bear. Their artillery, limited in number and capability, could harass American forces but could not seriously impede their advance. Japanese gunners fought with desperate courage, often continuing to fire even when their positions were being systematically destroyed by counter-battery fire. But courage could not overcome the mathematical reality that American forces could deliver 10 or 20 or 50 rounds for every Japanese round fired. The final assault on Mount Suribachi illustrated how completely American firepower dominated the battlefield. For 3 days before the infantry assault, American artillery and naval gunfire pounded Japanese positions on the mountain. Forward observers identified targets. Fire direction centers calculated firing data. Gun crews loaded and fired in smooth choreographed sequences perfected through countless hours of training. Shells rained down in concentrations that turned rock into dust and reduced Japanese fortifications to rubble. When Marines finally advanced up Suribachi's slopes on February 23rd, they encountered Japanese defenders who had survived the bombardment through sheer luck or the protection of deep tunnels. These soldiers fought with fanatic determination, but they were scattered, disorganized, and largely cut off from supplies and reinforcement. American forces systematically cleared each position, supported by flamethrowers, demolition charges, and portable artillery that could be called upon within minutes. By late afternoon, Marines had planted the American flag on Suribachi's summit in a moment that became one of the war's most iconic images. The contrast between American and Japanese artillery capabilities had profound strategic implications that extended far beyond individual battles. Artillery effectiveness influenced every aspect of military operations. American forces could conduct offensive operations, knowing that overwhelming fire support would suppress enemy defenses and break up counterattacks. Japanese forces had to rely on defensive tactics that minimized exposure to American firepower, tactics that were inherently passive and could not alter the war's trajectory. The disparity also affected training and doctrine. American artillery units trained extensively in peacetime, developing procedures and techniques that became standard practice. When war came, the military could expand rapidly, confident that new units would be trained to existing standards. Japanese artillery units had less opportunity for training as the war progressed. Experienced personnel were killed faster than replacements could be trained. Equipment wore out and could not be replaced with equivalent weapons. Ammunition shortages forced gunners to conserve rounds, limiting training opportunities. By 1945, the gap had become unbridgeable. American artillery units employed sophisticated techniques, including time-on-target missions where multiple batteries fired at different times so that all shells arrived simultaneously, flash and sound ranging to locate enemy guns for counter-battery fire, and proximity-fused shells that detonated at optimal height for maximum effect. Japanese artillery remained dependent on basic techniques that had been current during the First World War. The psychological burden on Japanese gunners was immense. They understood they were fighting with obsolete weapons against an enemy whose technological superiority grew, more overwhelming with each passing month. They knew that every time they fired, they risked immediate and devastating counter-battery response. They watched as American forces advanced with apparent impunity, protected by artillery fires that Japanese forces could not match. And they knew that their sacrifices, however honorable, could not change the war's outcome. Lieutenant Masao Hayashi, commanding a gun platoon on Iwo Jima, left a final letter that was discovered after the battle. The letter, addressed to his family but never mailed, expressed thoughts that official military culture forbade. Hayashi wrote that he and his men had done everything asked of them. They had trained diligently, maintained their weapons as best they could with limited resources, fought courageously against overwhelming odds. But courage and dedication could not overcome the fundamental reality that Japan lacked the industrial capacity to supply its military with weapons comparable to those the Americans fielded. Hayashi's letter continued with observations about what he had learned from fighting Americans. He noted their systematic approach to warfare, their reliance on coordination and firepower rather than individual heroics, their apparent confidence that superior resources would ultimately prevail. These were not criticisms but acknowledgments of different approaches to warfare. Japanese doctrine emphasized spiritual strength and aggressive action. American doctrine emphasized systematic application of industrial power. On Iwo Jima and across the Pacific, the American approach was proving decisively superior. The letter concluded with Hayashi's acceptance that he would not survive the battle. He expressed pride in his service, love for his family, and hope that Japan would find a path forward after the war. But he also expressed something rarely acknowledged in official Japanese military communications: the recognition that Japan's military leadership had committed the nation to a war it could not win, sacrificing a generation of young men in pursuit of objectives that industrial and economic realities made unattainable. American veterans who survived Iwo Jima and the Pacific War carried different but equally profound insights. They had proven that American forces could defeat Japanese troops in brutal close combat on terrain that favored the defender. They had demonstrated that American industrial power could be translated into military victory when properly employed. But they had also witnessed the terrible human cost of war, suffering that affected both sides regardless of technological advantages. Corporal Hendricks returned home to Pittsburgh after the war and resumed work in his father's machine shop. But he never forgot what he had learned on Iwo Jima's black beaches. He spoke occasionally to engineering students about the relationship between industrial capability and military power, explaining that wars were ultimately contests between entire societies, not just armies. Victory required not just brave soldiers but functioning factories, trained workers, adequate raw materials, transportation, infrastructure, and all the complex systems that sustained modern warfare. The abandoned Type 92 battalion gun that prompted such derisive laughter in February 1945 became, in Hendricks's later understanding, something more complex than a symbol of Japanese inferiority. It represented the limitations that constrained Japanese forces throughout the war, limitations that Japanese soldiers and workers struggled against but could not overcome through courage or dedication alone. The gun's crude construction and poor performance were not evidence of Japanese incompetence, but rather symptoms of systemic constraints that affected every aspect of Japan's war effort. This understanding brought a measure of respect for Japanese soldiers who had fought with obsolete weapons against overwhelming odds. The Marines who laughed at captured Japanese artillery had also buried comrades killed by that same artillery, had seen Japanese soldiers fight to the death rather than surrender, had witnessed determination and courage that commanded respect even from enemies. The technological gap was real and decisive, but it did not diminish the human qualities displayed by soldiers on both sides. The lessons learned on Iwo Jima about artillery and industrial power influenced American military thinking for generations. The experience reinforced beliefs about the importance of technological superiority, the value of overwhelming firepower, and the necessity of maintaining industrial capabilities that could support military forces in sustained conflict. These lessons shaped American defense policy through the Cold War and beyond, informing decisions about weapons development, force structure, and strategic planning. For Japan, the post-war reckoning with military defeat included honest assessment of the industrial and technological limitations that had constrained the war effort. Japanese engineers and industrialists studied American manufacturing methods, quality control procedures, and production techniques. They learned from defeat, applying those lessons to rebuild Japan's industrial base along lines that emphasized precision manufacturing, quality control, and technological innovation. The transformation was remarkable. Within decades, Japan became a global leader in manufacturing, producing goods that set world standards for quality and reliability. The irony was profound. Japanese industry, freed from military domination and rebuilt according to lessons learned from defeat, eventually achieved levels of precision manufacturing and quality control that exceeded those of many Western nations, including America in certain sectors. The same nation whose artillery had been laughably inadequate in 1945 became renowned for manufacturing excellence by the 1970s, 80s. The transformation demonstrated that Japanese workers and engineers were never lacking in skill or dedication. What they had lacked during the war was time, resources, and the accumulated industrial infrastructure that mature economies possessed. The human stories behind the statistics and technical details are what give meaning to history. Lieutenant Morrison survived Iwo Jima and returned to civilian life, eventually becoming an engineer like his father. Private Kono died on Iwo Jima, one of more than 20,000 Japanese casualties. Lieutenant Hayashi also perished in the battle. Corporal Hendricks lived until 1998, long enough to see Japanese manufacturing quality become legendary. These individual lives, and millions like them, were shaped by decisions made in capitals, far from battlefields, decisions about industrial policy and military strategy that determined whether soldiers would fight with adequate weapons or obsolete ones. The captured artillery piece that inspired such laughter in February 1945 stands now, in our understanding, as testimony to something larger than technological failure. It represents the human cost of industrial competition, the tragedy of young men sent to fight with inadequate tools, the cruel mathematics of modern warfare, where resources and production capacity ultimately determined outcomes more surely than courage or skill. It reminds us that wars are not abstractions, but human experiences, that behind every weapon are workers who built it, soldiers who used it, and families who mourned those who died because of it or despite it. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.